Your model hits 95% accuracy in training. But in production, it drops to 70%. This is training serving skew, a silent killer. Why? Feature computation diverges. A data scientist uses Spark for transformations, an engineer re-implements them in Go for serving. Subtle differences creep in, a rounding error, a time zone mismatch, or a window boundary handled differently. The model degrades inexplicably, and debugging becomes a nightmare because the failure is hidden. To solve skew, look at the ML infrastructure stack. It has 5 layers: data ingestion at the bottom, then feature computation, training pipelines, model serving, and monitoring at the top. Successful teams spend 80% of their effort here. It's platform engineering work. The critical layer is feature computation, where skew originates. This is where a feature store sits, acting as a single source of truth to ensure identical logic for both training and serving, preventing those subtle divergences. Now, dive into feature store architecture. It has 3 components: a feature registry for metadata, an offline store like BigQuery for historical data in training, and an online store like Redis for low-latency inference. A single computation logic writes to both stores, zero skew. For pipelines, batch runs on a schedule, like hourly, and is cheaper. Use it when freshness isn't critical. Real-time processes events in seconds, needed for fraud detection. Avoid the complex Lambda pattern, prefer Kappa for streaming or batch only when possible, matching latency to your model's sensitivity to data staleness. With this architecture, build reliable systems. Data versioning with tools like DVC ensures reproducibility. Trace any prediction back to its source data. Model serving requires deployment rigor, canary rollouts, auto-scaling for GPU loads, and latency budgets. Monitoring catches silent failures early, for example, input checks flag if a feature value jumps from 0 to 1 to thousands. Feature stores are key. They prevent training serving skew, enable reproducibility, and with proactive monitoring, turn ML from fragile to robust infrastructure.